Alright, so an inflection point needs two things to happen. Concavity has to change, and it has to be a point on the graph. More often than not, you guys don't check the point part, and that sometimes will make you miss some questions. But they occur when the second derivative is 0 or undefined. So you should have taken the second derivative, seen that this doesn't have x in the denominator, so it's never undefined, but he does equal 0 at 1/6. And when x is 1/6, this is a possible point of inflection. We don't really know if it's an inflection point until we see if the concavity changes. So maybe test a point to the right of it into the second derivative, see you get something positive, so it's concave up. Test a point to the left of it, like 0 into the second derivative, to see that you get something negative, so it's concave down. And now that I can see that the concavity is changing, and if I plug this into the function, I don't know what that comes out to be, but I know it exists, so I know it's a point. It's a point, the concavity changes, so no longer possible point of inflection, it is an inflection point. X equals 1/6. So the one nice thing about this, as we get a few questions under our belt here, the derivative and what you're testing for, the things you have to know, are not too terribly difficult once you get the hang of them. The work is not all that bad. But if you don't know what an inflection point is or how to find it, if you don't know where that comes from, then yeah, you're done pretty early in the question. Okay, any follow-up to this one before I push it away?